welcome to the second part of the winglet construction video. I'm Raul Klingberg, your host. In this first photo, you see what I consider to be the most critical part of the construction process, and that's the alignment of the root rib. The root rib or the base rib has to align accurately with the winglet mount, and it has to run smoothly, and it provides the guide for the rest of the construction. So it must be absolutely square and level. I'm using a square here to ensure that it's perpendicular to my building surface, and the ramp at the trailing edge of the rib ensures that the rib is absolutely horizontal. I essentially take the thickness of the rib, divide that in half, and that's the height of the ramp at the trailing edge of the rib. Once this is aligned, and as you can see I'm using tape to hold the pieces in place, I apply a small amount of CA glue to tack the rib to the lower spar. And once that's done, I can proceed with the rest of the construction. In this next photo, you see the alignment of the tip rib. I'm using the square to ensure that it's vertical to the building surface and therefore aligned with the root rib. And you see a level on the other side. I'm going to show you in a moment how that's set. And the trailing edge of the rib is on the ramp to ensure that it's horizontal. In this shot, you can see that I've tack glued a small strip of balsa right on the cord line of the rib, and this little shelf provides a place for me to set a level, and I can fiddle with the rib and the ramp a little bit to make sure that it's absolutely level, so we have the rib both vertical and level. It's all aligned with the root rib so we don't have any twist or accidental washout in the winglet, and once it's aligned I can tack glue it to the lower spar. In this next shot you can see that I've slipped the trailing edge material between the ramp and the rib itself. The trailing edge material is made of 1/64 inch thick plywood with unidirectional carbon fiber applied on the inside. How I actually made this material, you can see a video on that elsewhere on my site. Please go take a look at that if you're curious. The one thing I want you to note in this photo is that the rib itself does not extend all the way to the aft edge of the trailing edge material. It is inset about a 1/4 inch or so, and that's to allow the trailing edge material to actually come together tightly and minimum thickness at the back. If the rib ran all the way to the aft edge, you'd have a bump at each rib, and there'd be gaps perhaps on the trailing edge or waviness. So the ribs always have to be set slightly forward of the aft edge of the trailing edge material. Here you can see that I've slipped the trailing edge material underneath the tip rib, and I've aligned it in the same fashion that I used for the root rib. Once I have the trailing edge material in the proper place, I tape it to the ramp, make sure it doesn't move around, and then I glue the tip rib to the carbon fiber trailing edge. I use epoxy adhesive for final bonding of all the. In this photo you can see that I've applied the leading edge tubing to the root and tip ribs, and it's held in place with just tape at this point. And I'm beginning to align the number 2 rib, which is Dow styrofoam. You'll note that there's masking tape on the leading edge tube at the location of each rib, and the purpose of this is so that I can remove the leading edge from the assembly and wrap sandpaper around the leading edge tube at each one of those locations, and then go and sand the leading edge of the foam ribs so that they'll match identically with the shape of the tube. Given the angles involved, it's a very hard thing to cut by hand. It's just much easier to sand it to an exact match. This next photo shows one of the classic occurrences when designing and building a new aircraft, whether it be model or full scale. This happens on a regular basis, at least it does to me, and it's one of those gotchas where when it happens you think, oh shoot, why didn't I think of that? It just didn't dawn on me. And what's happened here is that the foam ribs prove to be too flexible near the trailing edge. Because they get so thin before they get to the trailing edge material, they're flexible in bending, and could not be aligned and held in place properly. Plus, they were too soft for the follow-on building steps. And if I would have thought ahead, I would have applied balsa wood to the foam before I shaped the ribs, such that when the rib is shaped, the forward portion is foam, and then that last little portion would be balsa wood and provide the stiffness that's needed. So what I did here, instead, to avoid throwing these ribs away, I took little pieces of 1/64 inch thick plywood, marked and cut them to shape to match the rib, and glued one to each side of the rib. A lot of fiddly work. I certainly wouldn't do that again. If I hadn't already cut out all the ribs, I would have gone in with the balsa method of applying just a strip of balsa wood at the back edge of the foam and then cut out the rib shapes, and they'd be plenty stiff then. So a little fix here. Had to take about an extra half hour or so to glue all those little pieces on, and then I can move forward with installing the foam ribs. So each one of the ribs that you see on the table has been sanded to shape to match the tube, and then I'm following the same process that I used for the root and tip ribs to align each one of those foam ribs. This is a quick shot to show you how I use clothespins in my construction process. They're cheap, they're handy, and if they get gummed up with glue, you just throw them away. I'm using a clothespin to make sure that the trailing edge of the foam rib is securely in place on the trailing edge material, that there's no gaps, and I'm using 5-minute epoxy adhesive to glue all of the ribs to the trailing edge material. On the second winglet, I used urethane glue, like Gorilla Glue, and I found both adhesives to work quite well and be sufficiently strong and about the same weight. So it depends on how much of a hurry you're in and how much money you're willing to spend. Less time, more money, use the epoxy. A little more time, less money, use the urethane adhesive. This photo shows another critical part of the process of constructing these winglets. This is the installation of the pole-treated fiberglass tubing that provides the pivot for the winglet. It is critical that this tube be absolutely perpendicular to the root rib so that the motion of the winglet in flight is accurate and does not bind with the mounting base. We want it to run nice and smooth, and we don't want the winglet to go out of alignment during its travels. So this tube must be absolutely perpendicular to that first rib. So I'm using a square here to ensure it's that it's perpendicular to the surface of the rib fore and aft, and then I'm using spacers underneath to ensure that the tube is perpendicular in a transverse direction, which you'll see I measure in the next photo. Here's how I set up to ensure that the tubing was perpendicular in the transverse direction. I've put foam and a couple different types of foam underneath to fill up the gap, and then I'm using thin sheets of balsa wood underneath to do the final trim out to make sure that it's level. I have a level taped in place on top of the tube, and I have a good 6-7 pound lead weight there on one end to make sure nothing moves around. And once I have everything aligned fore and aft and side to side, then I tack glue it in place with some CA glue. You should also note that the pole-treated tube, the pivot tube, actually goes up and touches the number 2 rib, but it does not penetrate into it. I push a little bit by hand to shove it a little bit into the foam to create a little dent there and a ring shape that the tube sits in once I have it in place, and that helps steady the tube while I'm doing the tack gluing. I also tack glue that end of the tube to the rib, and of course the CA glue that I use for that has to be foam safe, or you can use 5-minute epoxy or Gorilla Glue, whatever you like to work with. Once the pivot tube is secured in place, I check the notches on all of the ribs to make sure they can accept the upper spar, and then I drop that spar in place and glue it to each rib, put some weights on top to hold it in place while the glue cures. You could use 5-minute epoxy, which I did for this winglet, or the Gorilla Glue, urethane glue, which I used for the other winglet. Either one's fine. Just make sure that before you move forward from this step that the adhesive is completely. At this point in the process, I've also bonded the leading edge tube in place to all of the ribs. You can use just about any adhesive you want here, urethane glue, epoxy, anything will be fine. Most of the loads are carried by the leading edge sheeting, so as long as the ribs don't move around during that sheeting process, you're fine. In this photo, I'm showing the installation of the shear web between all of the ribs. This is from rib 2 to the tip rib. This shear web material is 1/64 inch thick plywood, and the face grain is arranged so that it's running vertically. In other words, from the bottom or from one spar to the next spar. I hold them in place while the glue dries with some clothespins, and I'm using 5-minute epoxy for this process. My initial plan was to install shear webs on both the front and aft surfaces of the spars, but as it turned out, when the shear webs were in place on the front side only, structure was stiff enough, so I skipped putting them on the aft face and saved some weight. In this photo, I'm installing the shear web in the number 1 rib bay. That's the space between the root rib and the number 2 rib. This shear web is 1/16 inch thick plywood with the face grain running parallel with the spars and with the pivot tube. I oriented the wood in that direction because I wanted the extra strength aligned with the pivot tube, and a little easier to actually make the part and deal with it this way. You'll notice the cutout for the tube is not accurately shaped to the tube, and that's okay because that's going to get filled with composite adhesives later. This photo shows the installation of the second shear web that goes on the aft side of the spars. You see that I have a hole cut in the shear web to allow passage of the tube. Once again, this hole doesn't have to be accurate, it just has to clear the tube. We're going to reinforce it later. This shear web is actually made in 2 pieces, and even though it's very hard to see in the photo, there's a seam that runs vertically, so there's a forward portion of the shear web and an aft portion that allows it to fit around the tube, and those joints will get reinforced with composite materials later. In this photo, I'm installing a sheet of 1/4 inch thick 6 pound per cubic foot Divinycell foam. The foam is cut to fit tight to the pivot tube and the shear webs, and it spans the distance between the number 1 rib and the number 2 rib. The foam at the root rib, where you can't see it, actually extends all the way back to the trailing edge, and then I just cut it off square up to the number 2 rib. The purpose of this foam is twofold. Number 1, it prevents bending of the root rib when the fabric is shrunk, and the sheet also provides a support for the pivot tube and a place to wrap around some carbon fiber cloth and epoxy to make sure that that tube can carry all the flight loads and transfer those loads into the winglet structure. If you look closely in this photo, you'll see that I've applied a mixture of T88 structural adhesive mixed with pulverized cotton fiber, which is cotton flocks, to the area where the tube penetrates the shear web and filled the space between the shear web and the rib and completely covered up the tube. I'm then going to use some straight T88 structural adhesive to apply carbon fiber fabric over the top of that, smooth the whole thing out. So the very end of the pivot tube will be securely attached to the shear webs and hence attached to the spars. Here we have a photo that's a little bit out of sequence. You'll see that the trailing edge and leading edges have been applied on the surface, and I've took this photo out of sequence, but I wanted to slip it in here so that you could see how I applied carbon fiber fabric to the Divinycell foam and pivot tube. The gap between any gaps between the tube and the foam were filled with cotton flocks before application of this cloth, and then I used structural adhesive to bond to the carbon fiber cloth in place, and the cloth actually wraps around the tube and onto the other side of the Divinycell foam. so that that tube is secured in place. You could probably destroy the entire winglet, and the only thing left would be the stub of the spar and that tube. So it is very strong and also very lightweight. I was very happy with the results, how it came out this way. This was kind of built on the fly. Didn't have a strong plan going into this, but the end result was quite. At this point here, I'm going to give you a little teaser of the following steps about making of the sheeting for the leading edge and applying that sheeting and applying the final trailing edge piece. I hope you come back in 3 or 4 days and see part 3 of the winglet construction, where we're going to finish this up and get it ready for covering. And once again, thanks for coming. If you're one of my patrons, oh, God bless you. You are making key parts of this project possible, and I hope you stick with me. And if you're on YouTube and you're not a patron yet, please, 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 please give some consideration. It's just a few bucks a month, and you can really help move this project along. Thanks for listening, and see you soon. Bye now.